YouTube has over 122 million daily users watching billions of hours of videos per day, including this one. However, some of these videos can have a very misleading thumbnail and title, which we call, of course, clickbait. So I wanted to figure out what exactly makes a YouTube video clickbait or not, and use that knowledge to create some machine learning models that could predict the likelihood whether a given video is clickbait or not. Like this one, because YouTube decided to remove the dislike button when I was in the middle of this freaking project, and now I have to salvage what's left of this plane crash, which I created a GitHub repo for in the description below, which you can find along with the dataset that I created for this project. To get the data from the YouTube videos, I used the YouTube Data v3 API, wrote some functions to retrieve the thumbnail, title, statistics from a given video that gives me the JSON files that I then converted into CSV files. And then, to get the non-clickbait videos, I just randomly selected 100 videos from the Explore page and manually checked to make sure they weren't clickbait. I chose Explore page for a very good reason, just so that the machine learning algorithm doesn't automatically assume that a video with more views is more likely to be clickbait, because there are videos with a lot of views that are most certainly not clickbait. As for getting clickbait videos, I wanted to ideally get thousands of different examples of clickbait videos, but I ran into kind of a catch-22 loop in that I needed the finished product of this project to start the project, which is like an infinite recursion halting problem type mumbo jumbo. So I unfortunately manually had to select 100 different clickbait videos, and I hope the amount of brain cells I lost doing that can be made up for with some astute insights. For example, clickbait videos are much more likely to have a lot less balanced video statistics due to their weaker correlations if you look at this correlation matrix right here. Clickbait videos are also have a much wider distribution of dislikes if you look at this distribution graph right here, which makes sense as the viewer is likely to dislike a video after being misled by its title and comment. Thus, clickbait videos also have a significantly smaller distribution of dislikes to likes than non-clickbait videos as well. Clickbait titles often have very extreme attention-grabbing verbs, such as believe, hack, caught, and prank. That's a classic one from 2010, to form titles like You Won't Believe, or Prank/Hack Gone Wrong, while non-clickbaits are usually going to have more mild nouns, such as the ones I picked, have highlights, games, official, just videos that have normal verbs, you know. Looking at the thumbnails, a key indicator of a clickbait video is that these thumbnails use brightly colored arrows or circles, as well as a strongly emotional or very surprised facial expression of the video creator. Non-clickbait thumbnails are typically identified as having one, maybe, or just none of the videos featured in the clickbait thumbnails. A non-clickbait video can still be extreme, but they're usually, on average, not as extreme as the clickbait videos. If a YouTube video is clickbait, I hypothesize that it'll have a much lower like-to-dislike ratio than a non-clickbait video, because more people will dislike the video after, being lied to. As a result, I created a new feature which is called dislike to like ratio, specifically, just so that I don't get giant numbers. It's the inverse of like to dislike ratio. As for the rest of the video statistics, I normalize them, which is like scaling down to a normal distribution, which is a very common machine learning technique so that our model won't miscorrelate large values with clickbait or non-clickbait classes. I also unfortunately had to remove non-ASCII characters, and despite me wanting to keep the eggplant emoji and the peaches found in a couple of the clickbait videos I used, the Windows 10 file system just said. Now onto the fun part where I ensembled together, get ready for this, a random forest, a k-nearest neighbors, a support vector classifier, a XGBoost classifier, a logistic regression classifier, and not a Gaussian naive Bayes classifier. Put them all together with soft voting in an ensemble. And I use soft voting because I want to display probabilities, instead of just yes or no binary values. I exclusively fed this particular model the video statistics, and it ended up performing, really okay. It's not great. So what I did was I chose a different model for the title. I specifically chose the Google Universal Sentence Encoder, and it was a really, really beefy boy. That is 1 gigabyte. And it crashed my Colab notebook so many times that in the end, I ended up getting a 97% accuracy, which I'm pretty sure is due to overfitting. Don't quote me on that. I don't have enough videos to prove that my 97% accurate model will work on all YouTube videos because I don't have enough data to back it up. But what I did was I combined these two models together into yet another ensemble model. I'll let you in on a little secret. Ensemble models are the way to win Kaggle. no competitions. And just as this project couldn't get any better, right when I was exporting this model, that's when YouTube decided to remove the dislike button. And as a result, I couldn't query dislikes off YouTube videos anymore. Gotta love those corporate incentives. My end goal was to use this model in a full-stack web application, which I can still technically make using the title classifier, and I may do that in a future video. But for now, I just wanted to publish my results here in analysis. You know, if I had more resources such as infinite YouTube API requests or powerful TPUs to train with, then I would use millions and millions of YouTube videos as data. Though then you would run into a problem where you kind of have meta clickbait videos, such as non-clickbait videos that are extreme, where the video isn't itself clickbait, but then it's kind of... the creator made it look like clickbait when it's actually not clickbait, so it's kind of meta clickbait, and I would have to somehow either make a third class or just explain it, or I have no idea how the hell I would do that. I could also use unsupervised learning to cluster together videos likely or not likely to be clickbait, and then use them as training examples with self-supervised learning. I actually did try to use the thumbnails as possible training features. However, with a lot of the CNN models that I found on TensorFlow Hub, I found that I got a very low accuracy with using them. And that is because there are plenty of videos on both sides of the classes that have contrasting colors, surprise facial expression, punctual shapes, that aren't exactly clickbait, but may appear clickbait depending on the viewer's opinion. Deciding if a video is clickbait is not 100% objective. There is some opinion involved in there based on the videos you've seen in the past. And I do think that analyzing the sentiment of like the top 10 most liked or pinned comments would increase accuracy as well. A possible software solution could be used by any YouTuber in the form of like a web application, as I recommended. And because most YouTube videos are watched through your cell phone, that web application would have to work really well with a mobile device. So, I mean, you can just use Bootstrap with it, and it works fine. But overall, the biggest lesson I learned from this is to not have the core functionality of your app and project be from an API from a platform that you don't have control over!